So, hello and welcome to Devcom 2020 and our talk Emotion AI in Video Games. In this talk, we're going to talk about emotion AI, but from a whole different perspective. You know, things you hear about AI are totally different. They're talking about game testing and so on, but this is a relatively less touched topic. In this talk, we're going to talk about the history and vision, and then go behind the scene to see actually how we came to create this level of immersions, this level of interactions one by one. And then afterward, we will talk about the role of emotions in games. And lastly, we will just conclude, all right? So, my name is Soroosh Mashal, and I work with Audering GmbH in Munich, actually, not so far away from here. I mean, well, physically, if we were here, actually, but sadly, this year we are not, so yeah. And we work on emotion AI through audio. We have a product called Entertain, which actually does that, and I'm the product owner, hence I'm here to talk about it. So let's talk about history of interaction in computers. Well, if you're 80s, 90s child, you probably have played all of the video games, and you had experience with all of that, right? So, talking about, do you remember? The first things are buttons, actually. Buttons are binary. They are like 0, 1, you know, and they are really simple, but really intuitive to work with as well, right? And after buttons, we started with joysticks, right? So joysticks, did you have those Ataris, you know, that you had to actually control the plane with them? Oh my God, I remember those days. So, those joysticks were a one-directional or two-directional control. So you already had a measurement, and they were, first of all, they were clicking actually, if you remember the first version. But the version afterward actually had the whole spectrum covered. So that was a more intuitive control that you had over 2D. Then you had the mouse, which was a really full control over 2 dimensions, and hence we saw that all of these FPS games, first-person shooters like Halo and so on, were created. That's all thanks to this new mode of interactions. Then, with the advancement of with the advent of smartphones, we could see the touch screens. So touch screen is still like 2D, but it is more intuitive because you can multi-touch, you can just touch the screen, and right now you don't need me to tell you how big the whole mobile game industry is. Like, it's literally taking over the rest, right? And right now, and afterward, so this was still 2D. Then we went for 3 dimensions, and we had these gadgets, like right now you have Oculus, you have Microsoft RealSense and so on. So at the moment, we are at the stage that we do have 3D input of all these gestures and everything you can possibly do. But the point is that if we are there, if we are at the 3 dimensions, and it's already fine-grained enough so that we can use it in virtual reality and so on, what is the next step, right? What's the question? Like, what is the better mode of interaction? What is the next mode of interaction? So for that, you have to think, what connects us more than anything else as humans? That's the question we need to answer. To answer that question, we need to look into our brains, right? If you know a little neurology and so on, you know that the emotional center of your brain has been evolved a lot sooner in comparison to other aspects, like other parts like frontal lobe, for example. And literally every input you receive through your senses goes through those parts like amygdala and so on until it comes to the surface and gets processed. So it means that I cannot really, like I'm not able to separate what you say from how you say it. Because first, my brain processes how you're saying something, and then after that, my brain starts to think, all right, so that's what he or she said. And that means we literally process emotions. We connect and interact with emotions whether we want it or not. Our brains are wired for it, right? So the answer is emotion. So we need to bring the whole emotional interaction into games, and that's our next step. But let's look at the games currently and see what is the stage we are. We do have this interaction, this cycle between us and the games. Games use their design, their storytelling, the challenges, and so on to make us really emotional, right? But usually you don't find so many ways that the games would actually get the feedback and understand whether they did it or not. There are some ways, they have been tried and they have actually been proven to work really good in scientific communities. You do see some of them implemented. For example, you have the in-game questions that ask you, all right, and try to get that feedback so that they would understand, all right, did that design actually work or not? Or were they actually aroused by the challenge introduced in the game? Or something like that. There has been projects with like biosensors attached to the body for horror games and so on. And there are other styles like, for example, eye trackings that you can attach to your VR, and then based on the eye tracking, you can somehow, find some emotions and so on. But there are some issues with them. They're not so scalable. So let's go behind the scenes and talk more about AI, how it works, because we believe in transparency. And we believe if you can actually understand how AI works, you can trust it. So for that, first we need some definitions. Let's start with feelings. Feelings is something that you have inside your brain, and it does not necessarily have any expression, any outside. It's not really visible from outside. Let me make an example. You can say like, I feel I know her, or I feel I know that. That's actually a feeling. There is a process inside your brain happening, but you can totally show something else. Or for example, another one is you're looking at somebody and it's like, oh my God, I feel I really like her, but what you're showing is like, so not showing it. So what the emotion you're showing is something different, which brings us to the definition of emotion. Emotion is that expression of feeling, that energy, like emotion. So when I start to express myself, when I start to show what my feeling is, that's emotion. Actually, we never want to touch feelings as well, ever, because feelings are for us private. Like emotion is something you decide to show, and that's already out, But feelings, no, we don't touch them. So we want to detect emotions. And then you have words like mood, for example, which is a diffused state of emotion. For example, if you hear something bad, you would be sad. But if you're sad over long time, every day, and you even don't know why, that's depression. That's a state, that's a diffused state. And then we have a word affect, which means the underlying process behind emotions, right? And affect is actually what we use to be able to model those emotions. Okay, on the whole era of artificial intelligence, where are we actually? If you get artificial intelligence, it's pretty much everything that humans can do and the machines learn to do it, right? And then we have this part of artificial intelligence that is called affective computing, which deals with affections. So affect, pretty much like that whole emotion and how that happens and so on. And there's a part in affective computing called audio emotion AI, which actually touches on what you say, and like how you say it, in your voice, through your voice. And it is, models have proven that this is not really language dependent. Based on language, the calibration changes, but humans generally express themselves really similar. Okay, so why audio emotion AI? Well, the answer is really clear. Microphones are everywhere. You do have microphones on your phone, on your laptop, literally everywhere. And besides that, talking is really a natural mode of interactions. You just hear radio, you just like listen. You can literally talk to somebody on the phone and it's completely enough for interaction. You literally don't need anything else. And it's also scalable. For example, the biosensors for your games, you cannot really ship games with like biosensor packages, attached to them so that they would start attaching biosensors to themselves and then they start playing games and so on. But microphones are everywhere already, so you don't need it. And it's not also invasive, so you don't have to just attach, put needles into your body so that you would just scan the brain or whatever. But how do we model it? So there are more. Let me just use 3D emotion space to explain to you how it works. The first thing is valence. You can either easily say the emotion is positive or negative, like happiness, sadness, right? And that's what we are going to use for the first axis. So something can be more positive or more negative based on, for example, let's say joy, happiness, and excitement. They are relatively more positive in comparison to each other, right? But joy, happiness, and excitement, if you think about it, they actually differ a lot more in something else, which is arousal, right? So for example, I'm like, oh my God, that's amazing. And then I'm like, oh my God, that's amazing. And then I would be like, oh my God, that's amazing. That's the difference between me being joyful, happy, and excited, right? And you can totally hear the difference in my voice. But there's more. There's more to it. So let me use a really easy example that you can differentiate. When you're panicking, somebody's after you, in the dark street, and they're just coming after, and then you're like, oh my God, you're running away. You're having a negative emotion, and you're also literally screaming, which means high arousal, low valence, right? And hold this. And then the other case is that your friend just does something really crazy, you're so angry at him, and then you're also yelling, so you're still having low valence and high arousal. But what is the difference between anger and panic? Think. The answer is control. Control is the third dimension we use to differentiate in audio. In control, so for example, the dominance in your voice. You can say, oh my God, don't do it, right? So that is anger. But then you can be like, oh my God, don't, no. That is panic. In the first one, I had really high dominance, really high control in my voice. But in the second one, I was actually really low on dominance and control. And we just construct this 3D emotion space, and then after modeling a bit, we find that every emotion has a corner. You can easily categorize emotions and see them matching in the corner somewhere on this whole space. And then based on that, we can just work with them. So let's look at emotions in games and some scientific studies and how that emotional input is working. So what does it mean for a company? Science shows that more using emotional interaction can mean more engagement and immersion for the gamer, which is also intuitive. And then this would lead to more player satisfaction. And then, of course, the more satisfied your players are, the more sales and profitability your company is going to have, right? So this is for you, but let's take another approach and see what does it mean for the whole society. It means that we are going to have widespread emotional interaction for kids, for everybody, all the gamers. And then this is somehow a passive training of a new generation to be more emotionally aware. And of course, when you have a society of people that are emotionally aware, you have a higher probability of a better world in which people are emotionally engaged and more sympathetic, and they understand each other better. And let's look at some applications that we can use. So we can either use it actively or passively. Actively is kind of like a direct input in the game. So for example, you are literally using it as like ordering your troops or something like that. And then passively, it's somehow like environment adjustment or like playtesting or parental control, for example. To that purpose, on 2019 in Gamescom, we had the Gacha Challenge, which was a game challenge for the first time, asking people to integrate emotion AI in games. And those are, that you see on the slides, they are the winners of Gacha 2019. One of the games was Destiny. ELISE'S Destiny was a TPS game that was using emotions as ultimate weapon. So you were shooting and you were defending in temple, but actually through your feedback, your ultimates were charging up. In addition to that, we also had like Black Market, for example, which was a fantasy puzzle game that was using emotions to unlock the chests, you know. And for example, in strategy games, we had people giving pep talks to your troops before the battle or like during the battle, and this would give them the enrage and buffs and motivate the troops. Or for example, in an RPG game, you can talk to the character, you know, ask for a discount, and depends on how friendly you are, you can easily get a discount. Imagine the level of immersiveness in such situations. Another one I mentioned is environment adjustment. So imagine a VR scenario that you can easily record audio from the head-mounted devices, and then you will just get the scores, of course, and then based on the emotion of the player, you can start to adjust and trigger events, and those events in turn make your player do something, and then this just goes on and on. So you would integrate it in the game in a really natural way. So what does it mean for the world, all in all? Let's see. We do have two possibilities for the future. One, both of them are advanced, of course, but one of them is a world that everybody is emotionally aware, everybody cares about emotion, and everybody is understanding each other and they are sympathetic. And the other world is a world that is totally void of emotion. Or not say void, but people are less sympathetic and they don't actually care that much. A world that people just order their virtual assistants instead of asking nicely. A world that people just talk to characters without even caring, and then in turn they also talk to people the same way. Which one do you choose?